Hey, so we're going to be finishing up Chapter 8 today with Lesson 6, kind of the culmination, bringing together all of the factoring that we've been working on, plus last time we talked about factoring the difference of squares. Today we're going to learn about one more special property of factoring that will be a little bit of a trick as you move forward in math, to be able to recognize things and factor them a lot easier. And then as we get further into these example problems in the lesson, I'm going to explain a little bit of how this is going to help you getting into Chapter 9 and something that you'll use a lot, especially once you get into Algebra 2 in a couple of years. So, I'm going to start off with perfect square trinomials. A perfect square trinomial is a trinomial that is the square of a binomial. So what that means is if I have the square of a binomial, that's going to be something like x plus 3 squared. Now when I do that, that's the same as saying x plus 3 times x plus 3. And then when I FOIL this, I'm going to have x squared plus 3x plus 3x plus 9. Which now I can simplify my like terms, and I get x squared plus 6x plus 9. And that would be my perfect square trinomial, because I got it by squaring a binomial. Now the difference here, last time again we talked about the difference of squares. That was where you had a binomial where both of your terms within it were perfect squares and you were subtracting. This time we have a binomial and we are squaring that binomial. So, in order to tell whether or not a trinomial is a perfect square trinomial, we have to follow these three conditions, and we need to do it in the order that I'm going to talk about them here. So the first thing we need to do is check to make sure that the first term is a perfect square. Because if the first term isn't a perfect square, then we know right there we don't need to go any further. This isn't a perfect square trinomial. In this case, it is a perfect square. So we would say our a value is going to be the square root of this first term, which the square root of 4x squared is 2x. Next, we need to go to step 2, which is actually looking at the c value, the last term, and it also has to be a perfect square. In this case, 25 is a perfect square. This is going to be our b value, which would be 5, the square root of 25. As long as both of those things are true, the last thing we want to look at is that middle value. The middle term must be twice the product of the square roots of the first and last terms. So whatever you found as your a and b terms here, you would want to multiply those together. So we would do 2x times 5, which gives us 10x. So that's the product of the square roots of the first and last terms. The middle term must be twice as much as that. So we would need to multiply that by 2, and it would give us 20x. So we see here that yes, the first term is a perfect square, yes, the last term is a perfect square, and yes, the middle term is twice as much as the square roots of the first and last. So this is a perfect square trinomial. Now in order to factor this, we would say that the factored form would be our a term, 2x. Since we are adding our b term, I'll get to this in a second, but you always want to look at the sign in front of your b term. Since it's positive, we would say plus whatever we got for b, which is 5, and we would square that monomial. So that is the factored version of 4x squared plus 20x plus 25. Now the patterns that you can follow here, the standard version of these perfect square trinomials, you're either going to have ax squared plus 2 times a times b plus b squared, or you're going to have a squared minus 2ab plus b squared. So we have those three rules that we talked about up there to be able to tell whether it's a perfect square trinomial. The last rule that really this could be the first thing you look at is that that last term cannot be negative. It can't be subtracted. Because if this last term is negative, you can't take the square root of a negative value. So if you have ax squared plus 2ab, that means that your answer will be a plus b quantity squared. If you're subtracting your middle term, then you're going to have a minus b quantity squared. So that's the pattern that you're going to be following as you go through and do these problems. Let's do some examples together now. So here, determine whether each trinomial is a perfect square trinomial. So that's taking those three steps that I talked about last time on the last slide. If so, factor it. So we want to see, first thing, is our first term a perfect square? 16, yes, the square root is 4. X squared is a perfect square. The square root is x. Now we want to look, so that, yes, that checks off. We're good so far. Second step, check to make sure our last term is a perfect square. Again, perfect square means the square root will be a whole number. Square root of 64 is 8. So yes, we're still good. Now we would need to do a times b, which would be 4x times 8. And then we would need to multiply that by 2, because the middle term has to be twice the product of your square roots of your first and last terms. So in order for this to be a perfect square trinomial, our middle term needs to be 64x, which in this case it is not. So we would say no, this is not a perfect square trinomial, which means we don't have to factor it. Let's take a look at this one. First term, yes, that is a perfect square. The square root would be 3y. The last term, yes, it's a perfect square. Square root would be 2. Then we want to check to make sure that the middle term is a times b times 2, which would be 3 times 2 is 6, 12y. So yes, that's good. So now we know we're going to have a binomial that we are squaring. We know that since we're subtracting that middle term, we're going to have subtraction within our parentheses. We're going to do a minus b, so a is 3y, b is 2. So our factored form would be 3y minus 2 squared. Again, as you get more comfortable with catching on to these, it'll make it a lot easier moving on when you're factoring to be able to see. You'll be able to catch that, yes, that's a perfect square trinomial. I can factor it right there without having to go through all the steps of factoring that we've done the last few lessons. One more here. First term, is it a perfect square? Yes, it is. N squared, the square root would be n. Last term, 144, yes, that's a perfect square. B would be 12. Now we need to make sure that the middle term is a times b times 2, so 24n, which it is. So it is a perfect square trinomial. So we're going to have a binomial squared. Again, we're subtracting that middle term, so it's going to include subtraction. We're going to have a minus b, so n minus 12 squared. So that's factoring perfect square trinomials. Now that we've learned how to do this, we're going to do a few problems here that are going to be kind of taking all of the different methods of factoring we've learned. So before we get into any examples, I want to go over this chart, which just is a reminder of all of the different types of factoring that we can use and which ones we use depending on how many terms there are in your polynomial. So, the first thing, remember, we always want to look for, no matter how many terms your polynomial has, if we're factoring it, first thing we always want to look for is a greatest common factor. Is there something that can be factored out before we do any other method of factoring? Then if there's only two terms, if there's no greatest common factor, the only type of factoring you can do with two terms other than greatest common factor is a difference of squares, which is what we talked about in the last lesson, a squared minus b squared, and it'll always come out to a plus b times a minus b. If there's three terms, this is kind of the order you want to take. You always want to check first, is it a perfect square trinomial? If it is, you can do what we did on that last slide. If it isn't, then it's going to be one of two methods depending on if it has a leading coefficient of 1 or a leading coefficient of something other than 1. And that's what we did a few lessons ago. Then if there's 4 or more, then you always want, and you've factored out the greatest common factor or there isn't one, then you're going to go to factoring by grouping. So we're going to kind of take all of those different methods here and we're going to factor a few polynomials here. So the first one, 4x squared minus 36. Now remember, no matter what, the first thing you want to look for is always to see if there's a greatest common factor you can take out. 4 goes into 4 and 36, so we can factor out that 4. We're left with x squared minus 9. Now we want to see, we've got a polynomial with two terms, meaning it's a binomial. Going back up to that chart, we already took out the greatest common factor. Our only other option is to see if we have a difference of squares. Here, our first term is a perfect square. It would be, the square root would be x. Our second term is a perfect square. Square root would be 3. So we need to bring that 4 down. X squared minus 9, since it's a difference of squares, we're going to have a minus b times a plus b, which would be x minus 3 times x plus 3. And that would be our factored form. So again, this is just kind of a review, a reminder of all the different types we've done so far. Now here, 25x squared plus 5x minus 6. First thing, always look for a common factor. There's no variable or number that we can take out of all three of these terms, so we can't do a greatest common factor. Next, let's see if it's a perfect square trinomial. 25x squared is a perfect square, so we're good there. 6 is not a perfect square, so we can't use the perfect square trinomial pattern that we've been learning. So now we're going to have to factor it normally, which means I'm going to draw in my x. I want a times c in the top. 25 times negative 6 will give me negative 150. My b value in the bottom, which is 5. So I need two terms that multiply to negative 150, meaning I'm going to have one positive and one negative, and that add to 5. So I know that my larger number needs to be the positive. I could use 15 and negative 10 here. If I multiply 15 and negative 10, I get negative 150. I add them, I get a positive 5. So now I'm going to rewrite this with that middle term broken up to my 15x and my negative 10x. So again, I just took that middle term and I broke it up into two different values. Now that I've got four terms, I can go ahead and factor by grouping. So this first one, I can take a 5x out, and I would be left with 5x plus 3. My second term, because I know that I need to have the same thing in parentheses, I need to have a positive, I need to have plus in my parentheses. I have minus right now, so I need to factor out a negative number. Here I can take out a 2. Since I'm factoring out a negative, it'll change the sign of both of these. I'm left with 5x plus 3. So now my factored form will be 5x minus 2 times 5x plus 3. Neither of these can be factored any further, so that would be my final answer. Again, anytime you're factoring, you can always check to make sure you got the right answer by foiling this back out and making sure it comes out to the original polynomial that you started with. So then the next thing we're going to talk about is solving an equation with repeated factors. So we've learned how to solve equations by factoring. We factor it out, set each one equal to 0. Now we're going to talk about a special circumstance here, but before I get to it, let's go ahead and factor this. 3 terms, there's no common factor, so my next thing I always want to look for is perfect square trinomial. A squared is a perfect square, so our a value would be the square root of that, which is a. Last term is a perfect square. B would be not 36, it would be the square root of 36, which is 6. Then my middle term needs to be 6 times a times 2, which is 12a. So that does work. Since I have addition there, my factored form will include addition, and it'll be a plus 6 quantity squared equals 0. Now, a plus 6 quantity squared equals 0. We could also write that out as a plus 6 times a plus 6 equals 0. Now we know in the past we've had to take each of those terms and set them equal to 0. Well here, if we set each of those equal to 0, they're both going to come out as a equals negative 6. So really, we only have to do it once. Now the other thing we could do is on this side where we have a plus 6 squared equals 0, we could take the square root of both sides. That gets rid of the squared. Square root of 0 is 0, so we get a plus 6 equals 0, or a equals negative 6. So what that means, repeated factors, we've got a plus 6 showing up twice, so we really only have to solve it once. Let's do one more of those. X squared minus x plus 1/4 equals 0. So no common factor we can take out, so let's see if it's a perfect square trinomial. X squared is a perfect square. 1/4, is that a perfect square? Remember, when you take the square root of a fraction, you're really doing the square root of the numerator and the denominator, and as long as they're both perfect squares, then the fraction is a perfect square. So the square root of 1/4 would be 1/2. Then the middle term should be 1/2 times x times 2, which 1/2 times 2 is 1, times x is x. So we know our factored form will be our a term. We're subtracting the middle term, so minus our b term squared equals 0. So again, since it's a repeated factor, it's the same factor being used twice, then we can just solve it once. X minus 1/2 equals 0, so x equals 1/2. Now I said that I was going to explain a little bit of how this is leading into the next chapter. In the next chapter, we're going to be working on graphing quadratic formulas. A trinomial like this is called a quadratic formula. We'll talk about that next chapter. But anytime we're solving by factoring, we're really coming up with the roots or the zeros or wherever the graph is going to cross our x-axis. So if we only have one solution, that means that the graph is just going to touch the x-axis. It's not actually going to cross through it twice. But again, that's just a quick view into what we'll be doing next. I don't want to get too far into it and confuse you guys more than you already may be. So again, anytime you factor a perfect square trinomial and you're using that to solve an equation, it's always going to have repeated factors. So then the last thing here is the square root property. For any number greater than 0, if x squared equals that number, then x is equal to plus or minus the square root of that number. So what that means is if I have x squared equals 4, using the square root property, if I take the square root of both sides to get rid of my squared there, then x has to be equal to plus or minus the square root of 4, which would be plus or minus 2, which means that the solution to square root of 4 could be positive 2 or negative 2. Because if you do negative 2 times negative 2, we get 4. So we're going to solve some equations using the square root property. Now the reason we have to do this is because this is squared. That means eventually, if we FOILed this out, we would end up with an a squared value, which means there has to be two solutions. So what we're going to do here is instead of actually FOILing this and then subtracting the 49 over and refactoring it, in order to get rid of that squared, we can take the square root of both sides, those cancel. So we would get a plus 4 is equal to positive or negative square root of 49, which we know the square root of 49 is 7. So it's equal to positive or negative 7. So now I'm going to take this and I'm going to break it up into two equations that I'm going to solve. My first one will be a plus 4 equals positive 7. My second one, a plus 4 equals negative 7. Subtract my 4 over, and I get a equals 3, and a equals negative 11. So those would be my two solutions there. Let's go ahead and do another one here. Again, since I have a square here, I can take the square root of both sides to cancel. So I get b minus 7 equals plus or minus the square root of 36, which is 6. Break it into my two separate equations. B minus 7 equals 6, and b minus 7 equals negative 6. Add 7, I get b equals 13, and b equals 1. Now, one thing you might run into, where they're not always going to be easy like this, where you're going to have perfect squares. So if we look here at this last one, when we take the square root of both sides, again, those cancel, x plus 9 is equal to positive or negative. In this case, we want to keep our answer as an exact solution. So that means we're not going to plug square root of 8 into our calculator and round it. We're going to keep it as x plus 9 is equal to plus or minus square root of 8. Now, this time, I have two options of how I could get my final answer. I could break it up into my two equations again. So x plus 9 equals the square root of 8, and x plus 9 equals the negative square root of 8. Then when I subtract 9, I could say x plus 9 equals negative 9 plus the square root of 8, or I could say square root of 8 minus 9. And then over here, x equals negative 9 minus the square root of 8, or the negative square root of 8 minus 9, either way. Or what I could do is go from here, x plus 9 equals plus or minus the square root of 8. I could go ahead and just keep it as one equation, subtract my 9 over, and say x is equal to negative 9 plus or minus the square root of 8. So I could give my solution as one solution that contains two answers because we have plus and minus, or I could break it up into my two separate solutions. Up to you guys, but remember, if you're solving using the square root property, if it's not a perfect square, go ahead and leave it as the square root so that we can get an exact answer there. So that is the last lesson of Chapter 8. There's your homework for that. Just so you guys know, we're going to finish up the year with Chapter 9. That's going to be the last thing that we're probably going to have time to do to be able to finish up the school year. Then I'm going to give you guys the last week or so is going to be some review from the chapters we've hit this semester. And then you guys will be doing your second semester final about the first week of June or so. And then you guys will be done. So we really don't have that much more. I think we only have like 6 or 7 maybe, more class periods for this class in this school year. So make sure you guys are getting this all done and finishing this year on a high note.